We're fixing our launch issues and our quality issues, and we're aggressively moving into battery electric.
Imagine never having to worry about finding a charging station to pull over your EV and recharging the EV, thus making the wonderful journey for a small period of halt and waiting for it to fill the max range. No need. Get ready to drive with the futuristic and innovative approach of Charge While You Drive technology, which will be a game changer for all the upcoming EVs in the world. Let's find out more about this wireless charging in EVs. Ford is one of the leading automakers in the world, and it's also investing in electric vehicles. Electric vehicles may have advantages, such as lower emission government and its cost and higher efficiency. However, it faced challenges such as limited range, lengthy charging time, and a charging infrastructure. To overcome these hurdles, Ford is exploring wireless charging technology that allows electric vehicles to charge their batteries without needing cables or plugs. Ford is exploring patent technology that could allow electric vehicles to charge while driving using hardware embedded in the road. Published by the United States Patent and Trademark Office on July 20, 2023, Ford's patent application titled Roadway Charging Coil Alignment and Monitoring deals with applying wireless inductor charging on vehicles in motion. The patent describes the advantages of inductive charging systems while in motion. In 2020, SAE International Family, the Society of Automatic Engineering, announced the first global standard for EV wireless charging up to 11 kilowatts. Wireless charging is not new. Various companies and researchers have explored it for different applications in vehicles. Well, where did this all start? We can go back in time. More than a century after the death of Nikola Tesla, Tesla's wireless power discovery is rarely credited to him. Thomas Edison is more commonly associated with the invention of electricity. However, his experiments were failures. Tesla's alternating AC currents provide a more reliable method of conducting electricity. In the late 19th century, Tesla's worked on the tower and explored electrical transmissions using radio frequencies resonance to create electrical energy through two coils to generate high-voltage, high-frequency current. This experiment used near-field inductive and capacitive couplings. The near-field inductive in a short-range wireless physical layer that transmits a lower-powered, non-propagating magnetic field between devices. This capacitive coupling transmits power between two networks by displacing the current produced by the electric field. So this theory of inductive electricity is now used in EV cars. The automobile company Tesla introduced this wireless energy transfers on EVs. When Tesla introduced the model, it had an innovative approach to charging the EV: recharge wirelessly. The Model S is an upgraded ultra-thin vehicle receiving coil that accepts inductive power transfer using existing connectors. A wireless charge base station is connected to a 240-volt circuit. This base station has a power transfer coil and a parking pad in a normal parking space. The wireless parking pad then converts the live electric power to magnetic energy, which can be safely transferred across the air gap to the receiver integrated under the Model S plastic shielding. The receiver then converts the magnetic energy written back to electricity. Ford was influenced by the wireless charging technology introduced by Tesla's Model S. The application discussed embedded inductive charging coils in the road and using them to charge vehicles while in motion. This requests the receiver on the vehicle to be aligned in a line of coils on the road surface. Ford notes that drivers could maintain a constant alignment by following lane markings or being guided by a camera or other sensors designed to read the landmarks. An Israel startup, Electrion Wireless, aims to create and build the first electric city road in the world with their demo project in Tel Aviv. The stretch between Tel Aviv and University and their main station will form a 2-kilometer distance. This concept enables me to charge while driving, ensuring energy can be fueled on the go and maximizing range. Electrion has tested this technology in other countries like Sweden and France. The company plans to deploy this technology infrastructure in the U.S., starting with a pilot in Detroit. The pilot scheme will partner with the Michigan Department of Transportation, which will provide $1.9 million towards the project. The project has been supported by Ford Motor Company, Next Energy, a Detroit-based organization focused on mobility technology, DTE Energy, and Dallas-based service company. We're excited to enter the U.S. market and collaborate with industry leaders to further enhance the country's mobility ecosystem, said Stephen Tonger, Vice President of the Business Development of Electrion in the U.S. Tonger said the company looked forward to working with departments of transportation, state and municipal agencies, and automotive and mobility industry innovators in Michigan, California, and New York on charging infrastructure that's vehicles agnostics and can be included in any electric vehicle. According to the project manager, another test in road charging for electric trucks on a stretch of Swedish road has been successful. The scope of testing will now increase with additional stretches of roads at a higher speed. In November 2019, the project Smart Road Gotland was initiated with the installation of inductive charging equipment on the structure of a stretch between an airport and the town of Visby on the Swedish island of Gotland. Testing took place in winter conditions with snow and rain over a week and a half. The truck could charge both voice stationary and while driving over a 164-foot section of road at speeds of up to 18 miles per hour. The system charged the truck to a rate of 45 kilowatts, according to Smart Road Gotland. Wireless charging a moving vehicle admin accomplished before, but not to the public. Renault and Qualcomm charged a car at 60 miles per hour on a test track. This property demonstrated changing up to 20 kilowatts at speeds of 100 kilometers per hour and higher. The demonstrated car was a pair of Renault Kangoo ZE electric small delivery van. Now, let's have a look at the advantages of the inductive charging coil in the road surface. Inductive charging coils can allow all electric vehicles to charge on batteries without cables or plugs. This can eliminate the hassle of finding and using charging station and make EVs more practical and user-friendly. This technology can also reduce the time taken to charge. An inductive charging coil can enable charging while driving, increasing the driving range and reducing the battery size. This can lower EVs' cost and weight, as it is also the range and sight that some EV drivers have faced before. This technology can allow smaller batteries that require raw materials and have a lesser environmental impact. Technology can reduce the risks of electric shock and other problems that may cause during wired charging. Inductive charging has no metal conduit to the environment, which can prevent corrosion of damage from dirt, snow, or water. This new technology can also avoid the hazards of high-voltage cables or plugs that may threaten humans. So we've seen the brightest side of the new and innovative technology approach. But there are some limitations regarding this new technology. Inventor and technology kill mastermind Nikola Tesla first demonstrated the potential of wireless charging in 1981 with wireless inductive energy transfer for lighting in incandescent bulbs. Electromagnetic compatibility (EMC), the unintentional generation, broadcast, and perception of electromagnetic energy, can create unwanted effects on vehicles' electrical system, such as electromagnetic interface (EMI). Temperature fluctuation is a major concern that every charging device or battery faces. A typical operating temperature for a smartphone is 0 degrees Celsius to 35 degrees Celsius. So the interior of a worker sitting in a parking lot on a sunny summer day can easily reach more than 37 degrees Celsius. And the same interior can quickly fall to 0 degrees Celsius on a winter day. Suppose the receiver is not properly designed and protected. EMC and temperature fluctuation can also affect the efficiency of the system. When transferring power from the platform to the receiver, some energy will be lost. However, this wireless charging can achieve efficiently only up to 45% under perfect conditions. Wireless charging modules were charging time, depending on the distance between the transmitter and the receiving module. The current technology available is to bridge the distance between 4 millimeters. Greater distances are possible only at higher transmitting power levels, which sports negativity after the EMC in the vehicle interior. Wireless charging is a relatively new and unfamiliar technology for many EV users, which can be concerning or raises doubts about the reliability, safety, and convenience. Wireless charging also competes with other alternative solutions for EV charging, such as battery swapping, robotic arm charging, or automatic mobile charging systems. Therefore, wireless charging needs to demonstrate its advantages and benefits for these solutions and address the possible barriers and challenges that may hinder users' acceptance and adaptation. While wireless charging is a new step in the development and innovative technology of EVs, this technology will be available in the next 3 years. This technology will be simultaneously charged to multiple devices and have downward compatibility. Ford is working with an Israel startup called Electrion to construct a mile-long road near Detroit that will use this technology. This project is expected to be operational in 2023. Will this Ford's new technology change the future of how we charge EVs? Or will the limitations or challenges possessed by this wireless charging take the upper hand in stopping the innovative approach? Don't miss out on the discussion. Like, share, and subscribe to our channel to follow this innovative automobile world.